In this video, we want to learn about factoring common factors. The easiest type of factoring occurs when the terms have a common factor. Look at this first example. 4a minus 6b plus 10c. Between these numbers 4, 6 and 10, we have a common factor. 4 is 2 times 2, 6 is 2 times 3 and 10 is 2 times 5. So the common factor between these numbers 4, 6, 10, the common factor is 2. So we can factor 2 from these three terms that here we have. By factoring 2 from these terms, we have 2 times by 2a minus 3b plus 5c. How we can make sure that our answer is right? Multiply 2 in the bracket. 2 times 2a is 4a. 2 times 3b is 6b. And because we have a negative, we have to put the negative. 2 times 5c is 10c. So in this way, by multiplying the terms that we factored in the bracket, we can make sure that our answer is right. But how we wrote the expression in the bracket here? When you factor a common factor, basically you are dividing by that common factor. When you factor 2 from 4a, basically you are dividing 4a by 2. 4a divided by 2 is exactly 2a. 6b divided by 2 is 3b. And 10c divided by 2 is 5c. So when you factor a common factor, you are dividing all the terms by that common factor. Look at the next example. We have 2x plus 6y plus 14. What is the common factor here? Again, look at the numbers 2, 6, 14. The common factor is again 2. So we factor 2. And then what we have to write in the bracket? When we factor 2, basically we have to divide every term by 2. 2x divided by 2 is x. 6y divided by 2, 6 divided by 2 is 3, so 3y. 14 divided by 2 is 7. And this is the factored form for this given expression here. Look at the next example. Negative 4x plus 12. We have a negative 4 and a 12 as the numbers. What is common factor between 4 or negative 4 and 12? Yes, the common factor is 4 or negative 4. It's up to you to factor 4 or negative 4. I will show you both methods for you here. Let's start with factoring just 4 here. So when we factor 4, then we have 4 bracket. What we have to write in the bracket? When we factor 4, basically we have to divide everything by 4. Negative 4x divided by 4, 4 with 4 cancelled, and then we have negative x. 12 divided by 4 is 3. So by factoring 4 in the bracket, we have negative x plus 3. But attention, in the bracket here we have a negative x. And we don't like to have negative x. Usually we prefer to have x, not negative x. We prefer to have x minus or plus something. We don't like to have a negative coefficient for x. It's completely fine, this answer. This answer here is 100% right. But the other way that you can do this question is to factor a negative 4. So the other way that you can do this question is to factor a negative 4. And then when you factor negative 4, let's see what happens. What is the answer? Then we have to divide this by negative 4, and we have to divide this also by negative 4. Negative 4x divided by negative 4, negative 4 with negative 4 cancels, and we have x. 12 divided by negative 4 is, 12 divided by 4 is 3, 12 divided by negative 4 is negative 3. So in the bracket we have x minus 3. Look at the two answers that we have here. One of them is 4 times negative x plus 3. The other one is negative 4 bracket x minus 3. Both of these answers are 100% right and they are the same, but which one is better? Usually, not necessarily, but usually we prefer this answer compared to this answer because we prefer our variable, which in this case is x, has a positive coefficient. Usually later, if you want to simplify your expression, this answer is a little maybe better. Let's move to the next question. X to the 2 minus 5x. Please pay attention. Here the coefficient, this number here is 1. We have a hidden 1 here basically. When you say x to the 2, it's basically 1x to the 2 minus 5x. Between 1 and negative 5 or 5, we don't have any common factor. The common factor is basically 1, so we don't have anything to factor. But when we look at these two terms, x to the 2 and 5x, if you pay attention, x is common. One of them is x to the 2. What is x to the 2? X times x. The other one is 5x. So x is common between these two. So here we don't have any number to factor, but we have a variable to factor. What is that variable? X. So we factor x from these two terms. Then we have x. What we have to write in the bracket? Again, similar to the previous question, when you factor something, basically you have to divide each term by that common factor. X to the 2 divided by x is just x, because x to the 2 is x times x. So one of the x from numerator with one x from denominator cancels, so x to the 2 over x is just x. Then minus 5x divided by x is minus 5. X with x cancels and negative 5 remains. So this is the answer, and this is the factored form for the given expression here. X times x minus 5. And how you can check that your answer again is right? Simply multiply x in the bracket. X times x is x to the 2. X times negative 5 is negative 5x. Now that we are a little familiar with factoring common factor, let's try some more examples and maybe a little harder examples. X to the 3 plus 5x to the 2. Immediately we notice that we have something in common here. And what is that common factor? X to the 2. So we factor x to the 2. And then we have x plus 5 in the bracket. Again, when you factor x to the 2, basically you are dividing each term by x to the 2. X to the 2, this should be x to the 2. X to the 3 divided by x to the 2 is x. 5x to the 2 divided by x to the 2 is just 5. Gradually, you can do the factoring common factor without basically dividing by that factor. But it needs, of course, practice. Look at the next example, which is a little hard. 6, 12. First, focus on the numbers. Always look for common factor between the numbers and then variables like x, y, and so on. We have a 6, we have a 12 or negative 12 and 15. What is common factor between 6, 12, 15? 6 is 2 times 3, 12 is 3 times 4, 15 is 3 times 5, 3 is common between them, so we can factor a 3 from these terms. So let me write 6, 3 here, because 3 is the common factor. In the first term we have x to the 3, in the next term x to the 2, and in the last term we have x. What we can factor? Can we factor x to the 3 or x to the 2 or x? Which one? The smallest degree of the variable. One of them, the variable is degree 3, the other one is a degree 2, the last one is x to the 1. And when you factor, you have to always factor the variable, the expression with the least degree. This is with the smallest degree, and the variable x is with the least degree in the last term, x to the 1. So we can only factor 1x, x to the 1. So we factor x, and then what we have to write in the bracket? We factor 3x. So basically we have to divide everything by 3x. 6x to the 3 divided by 3x is 2x to the 2. 12x to the 2 divided by 3x. 12 divided by 3 is 4. X to the 2 divided by x is x. So we have minus 4x. 15x divided by 3x, x with x cancels, 15 divided by 3 is 5, so plus 5. And this is the factored form of this expression here. Look at the next example. In the next example, we have two variables, x and y. First, as usual, we focus on the numbers, then the variables. 2, -8, 6. What is common factor between these numbers? 2, 8, 6. Yes, it is 2. So 2 is the common factor. Then we have x to the 2 in first term. In the next term, we have x to the 1. And in the last term also we have just x to the 1. So remember, always the smallest degree. Here we have x to the 2. Here we have x to the 1 and x to the 1. So we can factor only x to the 1 or x. Now look at y. Y to the 1, y to the 2, y to the 1. We can factor only y to the 1. So 2xy times y. Divide each term by 2xy, 2xy, and 2xy. 2x to the 2y divided by 2xy is x. 2 with 2 cancels. X to the 2 divided by x is x. Y with y cancels, and only we have x. This is for the first. Try to find for the next term. What is the answer of -8xy to the 2 over 2xy? X with x cancels. 8 divided by 2 is 4. Y to the 2 over y is 1y, so y. So finally, what is the answer? Negative. Don't forget you have a negative. Negative 4y. Finally, for the last one, 6 divided by 2 is 3. X with x cancels, y with y cancels, and nothing remains. So just 3 times 1 basically, or 3. And this is the factored form for this expression given here. Now look at these two examples. 2y times y minus 5 plus 3 times y minus 5. First, we look for numbers. Is there any coefficient, any number to factor between 2 and 3? We don't have any common factor. So no, we don't have any number as a common factor. Then here we can see that we have a y. Do we have any y here in the second term? Maybe you are thinking, yes, we have a y here. No, this is not y. Please pay attention. There is a bracket here. When you have a bracket, all of this is a term, not just this part of the expression. Look at this y. This is just a single y. And if you want, we never put, but if you want, you can consider a bracket around this y. This is 2 times by y times by y minus 5. So in the first term we have a y, but in the other term, in the second term, we don't have any single y. Yes, we have y, but that is y minus 5. It's not y. We want exactly y as the common factor. So y is also not the common factor. But when we look at this expression, right away we notice that, look at this, look at these two brackets. They are exactly the same. Y minus 5, y minus 5. Please pay attention again. If one of them was y minus 5, the other one was y plus 10. No, these are not same factor. And we cannot factor anything. But because the two brackets are exactly the same, so we can factor this common factor. So here, we can factor y minus 5, and then what we have to write here. When we factor something, we know that basically it's like dividing by that common factor. The first expression, the first term here, divided by y minus 5, this cancels with this. What remains? 2y. For the next one, when we divide 3 times by y minus 5 by y minus 5, this with this cancels, and what remains? Yes, only 3, so plus 3. So this is the factored form of this given expression here. So we don't need this big bracket, just a small bracket is enough here. Look at the next question, which is a little challenging question. This is not easy. I highly recommend you to pause the video here. Try this question by yourself. Don't get disappointed if you couldn't do this question, because this is challenging, but you can try. Why not? Let us start. When we look at this term and this term, these big terms, how I know that this is a term and this is another term? Because between them we have a plus. How we know that these two are two separate terms? Because between them is a plus or minus. This is one term, this is another term. So when you have plus minus, it means that you have a new term. So here in this question we have two terms. The first term is this big expression, and the second term is this one. Now that we know that we have two terms, let's see, do we have any common factor between them or not? If you pay attention, in the first term we have x to the 2 plus 9 to the 2. In the second term also we can see that we have x to the 2 plus 9 to the 1. So here these two are the same, but one of them is with power 2, the other one is with power 1. And we know that when we factor always the smallest degree. So we can factor x to the 2 plus 9 to the power of 1. And because the power is 1, you don't need to really write the power 1 for the bracket. Now look at this. We have a 4x here and we have a 12 here. Is there any common factor between 4x and 12? Yes, between 4 and 12 the common factor is 4. So it was better that first, when we look at these two expressions, we check for common factor between the numbers, but I forgot to do that. Between 4 and 12 the common factor is 4, so we have to factor 4 from these two expressions. And where we have to put that 4, it's up to you. You can put it exactly here and put a bracket because you want to multiply 4 by the other bracket, but usually it's better idea to put 4 in front here. This is the better way for writing your answer. Maybe you wonder why in the given question they put 4x here, not maybe here, or at least 4. Why they didn't put this 4 here, or like this one, because the 12 is in front but 4 is in the middle? The reason is obvious, because they want to trick you, they want to confuse you. The other thing is that when we see expressions like this in math, is it really a real question? Do we see expressions like this in future in other math courses? Yes. If you take calculus, when you take derivative of expressions, you will see expressions like this a lot, and you will see that your answer is exactly like this, that the 4x is in the middle. So it's not bad that you see expressions like this here in this video. when you see hard questions, gradually the other questions are very easy for you. So let's continue this solution. So far we know that we have x to the 2 plus 9 as a factor, as a common factor, 4 as a common factor. Now let's continue looking at the two expressions. X minus 1, x minus 1 to the 2. We can factor just 1 x minus 1 because the power of the first one is 1, so we only factor x minus 1. What we have to put in the bracket? We know that when we factor something, it's like dividing every single term by that common factor. If we divide this term by this, what happens? X minus 1 with x minus 1 cancels. 4 with 4 cancels. One of these x to the 2 plus 9 with 1 x to the 2 plus 9 cancels. So this goes away with one of these. So the power would be 1. Now look at this. What is remained here? X to the 2 plus 9 to the 1 and x. So in the bracket we have to write x to the 2 plus 9 times x. But please pay attention. When you want to write this expression here, you can write this expression in the form of x times x to the 2 plus 9. These two are the same, but which one is better? Definitely this one. This is not a good way for writing this expression. I know in the given expression they put x in the middle, but for yourself, you don't want to confuse at least yourself. It's better to put x here. So I'm going to erase this from here, and now I'm going to write it as x times x to the 2 plus 9. Now we have to divide this term by this common factor. When we divide x to the 2 plus 9 with this term, this cancels. 12 divided by 4 would be a 3, so this is gone. And x minus 1 to the 2 divided by x minus 1, this power goes away and it becomes 1. So we have a 3 times x minus 1. So at the end of the story we have plus, don't forget in the middle we have a plus, so plus 3 times by x minus 1. Let me briefly explain this to you. 12 divided by 4 is 3. X to the 2 plus 9 with x to the plus 9 is gone. And here we had x minus 1 to the 2. I erased the power here. We had a power in the beginning. 1x minus 1 from this expression, when we divide by this, is gone. And we have left with just x minus 1 with the power 1 in the bracket. And this is the factored form of this given expression here. If you want, it's not a bad idea to multiply this x here in the bracket and you multiply 3 in the bracket. But it's not really necessary. But let me show you what happens if you multiply x in the bracket and 3 in the bracket. Again, this is completely optional. Our job here is to just factor greatest common factor, which we did. But if you want, in the last bracket, you can do this. So we have 4 times x to the 2 plus 9 times by x minus 1 times by x times x2 is x to the 3. X times 9 is 9x. And then we have 3x minus 3. And in this expression, if you pay attention, you can write this as x to the 3 plus 12x minus 3, because if you combine these two similar terms, they are like terms. 9x plus 3x is 12x. And this is the final answer. Now look at these questions. Negative r to the 2 s to the 2 t minus r to s t2 minus r s 2 t2. The first thing that we notice is that we have a lot of negative coefficients, and we know that we hate negative. So it's a good idea to factor negatives. So the first thing that here we do is we factor a negative, because negative is here, negative is here, negative is here. So we factor a negative sign, or basically negative 1. Then in all the terms we have variable r to the 2, r to the 2, and in the last term we have just r to the 1. We know that we have to factor the smallest degree of the variable, so we can only factor r to the 1. The next thing that we can factor is r to the 1, or r. Then s to the 2, s2, so we can factor only s. And for t we have t, t2, t2, so we can factor only t to the 1. So the common factor between these three terms is negative r st. Then in the bracket, when we divide this by negative r st, negative with negative cancels. R to the 2 divided by r would be r. S to the 2 divided by s would be s. T with t cancels. So from the first term we have rs. From next term, when we divide this by negative rst, we have negative plus rt, because negative with negative cancels. R2 over r is r, t2 divided by t is t, and s with s completely cancels. What about the last term? From last term, if we divide the last term by rst with a negative, negative with negative is gone, r with r is gone, s2 divided by s is s, t2 divided by t is t, so st. So we have plus st. And this is the factored form of this given expression here. Now look at the next example. 2x to the 3 over 2 plus 3x to the 1/2 plus 5x to the negative 1. Usually in a normal algebra course, you would not see something like this, because the powers, the exponents are fractions. Usually we see expressions like this in more advanced course in math, like calculus. And in those courses you need to be able to factor the common factor in expressions like this. So it's good to learn these type of factorings. But in a normal algebra course, usually the exponents are integers, like 2, 3, 1. If you look at the previous questions, all the powers are 1, 2, 3. But here we have fraction exponents, 3 over 2, 1 over 2, negative 1 over 2. How we can factor this? Same as before. First we look for numbers. Is there any common number between 2, 3, 5? No, we don't have any common factor between 2, 3, 5. Now we look for variable. X to the 3 over 2, x to the 1/2, x to the negative 1/2. Remember, when we factor a variable, we always factor with the smallest degree. Between three numbers that we have as the exponent, which one is the smallest number? 3 over 2, 1 over 2, or negative 1 over 2? Yes, negative 1 over 2 is the smallest because it's negative. And so here we can only factor x to the negative 1/2, the variable with the smallest exponent. What we have to write in the bracket? In the bracket, to find what you have to write here, you have to divide every term by that common factor. Remember, when you factor something, it's like dividing every single term by that common factor. 2x to the 3 over 2 divide by x to the negative 1/2. What is the answer? We have a 2 in the top. The coefficient here is 1. 2 divided by 1 is 2. So 2. What is x to the 3 over 2 divided by x to the negative 1/2? Remember, when we have x to the m divided by x to the n, we subtract the power. It's x to the m minus n. Based on this rule for dividing powers, we have to subtract the power of the top from the power in the bottom. So basically, we have 3 over 2 minus negative 1/2. We subtract the power in the top from the power in the bottom. Negative times negative is plus, so 3 over 2 plus 1 over 2 is 4 over 2. Because the denominator is the same, we put one denominator, we add numerator. 4 over 2 is 2. So we have x to the 3 over 2 divided by x to the negative 1/2 is x to the 2. So 2x to the 2. Now we have to move to the next term. So let me erase here. What is 3x to the 1/2 divided by x to the negative 1/2? 3 divided by 1 is 3, so we have 3 here plus 3. Then x to the 1/2 divided by x to the negative 1/2 is x to the 1/2 minus negative 1/2. If you calculate this, is 1/2 plus 1/2, 1/2 plus 1/2 is 2 over 2, 2 over 2 is 1. So just 3x to the 1 or 3x. And for the last term, when we divide x to the negative 1/2 by x to the negative 1/2, this cancels and we have a 5. So plus 5. Because the powers are the same, the terms completely cancels. Or if you subtract the powers, you would get same answer. Negative 1/2 from the top minus negative 1/2. We subtract the powers. What is negative 1/2 plus 1/2? Negative 1/2 plus 1/2 would be x to the 0. Anything to the 0 is 1. So when you divide these two by each other, the answer is 1. 1 times 5 is 5. And this is the factored form of this given expression here. And again, let me emphasize, expressions like this appears a lot in calculus course and other advanced math courses. So it's good to learn how to factor, because when you face a question like this, never they teach you how to factor it. They expect that you know this already. I hope by watching this video you have learned what is factoring common factors and how we use this method, which is definitely the easiest type of factoring methods, but very, very important method. If you like this video, please subscribe in my channel and see you in the next videos.